welcome back to Science Bull Classes. Today we are going to discuss a question from the chapter Moving Charges and Magnetism. So it's a question given. In this question we are asked to find out the magnetic moment of this current carrying loop or square coil whose side length is 10 centimeter. It carries a current of 10 ampere. And we are asked to find out the value of magnetic moment in terms of vector form. Okay. So to solve this problem, just look from the top, view from the top, look from the top. So while viewing from the top, you can see only two axes, one is x, other one is z. So it can be redrawn as follows. This is the x axis and this one is the z axis. We can see only two axes, x and z. This is the x axis, this one is the z axis. We cannot see y, or y will appear as a dot. Now we can see this coil BC, this edge BC. The edge BC is represented as follows. This edge BC. Okay. This is B and this is C. And here the magnetic moment of this coil, it will act perpendicular to the plane. So this will be the direction of magnetic moment M. Okay. Now in the question it is already given this angle is 30 degree. This angle is 30 degree. And it is a plane, it is a normal. Magnetic moment is acting, is a normal to the plane. So this angle is 90, this angle is 60 degree. So if this angle is 60, then it is also 60 degree. Now you resolve this momentum. While resolving this momentum, one component will be along this direction, it is m cos 60, and the another component will be along this direction, this is m sin 60. So we can write the resultant momentum as this m cos 60 along x axis is positive I cap, and this is along minus z cap. So minus m sin 60 along minus k cap. Okay. So m is the product of current and area of the loop. The current is 10 ampere. This is a square loop, so area is 10 into 10 centimeter square, that is into 10 raised to minus 4 meter square. So it is 10 raised to minus 1 or 0.1 ampere meter square. This is the value of magnetic moment. So in vector form we can write m equals 0.1 cos 60 I cap minus 0.1 sin 60 k cap. That is 0.1, we know the value of cos 60, that is 1 by 2 I cap, minus 0.1, the value of sin 60 is root 3 by 2 k cap. So this 0.1 by 2, there is a common here. So it is taking out, it becomes 0.05 I cap minus root 3 k cap. So this is a vector form of the magnetic moment of the coil given in the question. Okay. Hope it's clear. Thank you.